Alright guys, moving on. So, we got Rutherford, right? We just did that. Rutherford's model, right? And Rutherford's model basically discovered the nucleus. Already has a nucleus, yes? And around it we said that electrons are traveling, freely around it. So the question is this, that some scientists asked guys. They said if opposites, right, attract, okay, and you have these electrons traveling around the positive nucleus, all right, how come what? How come the electrons don't just eventually crash into it? You have this moving body that's negative around this positive center, this core. How come there's no attraction and the electrons smash into it? So, along comes Bohr, Niels Bohr, all right? B-O-H-R, okay, famous scientist, okay, very brilliant, all of them are very brilliant, okay? He proposed what? He proposed something called energy levels, right? The atom has specific energy levels, so let me draw that real quick. So we have our nucleus still, nucleus still exists, the nucleus is still positive, right? But around that nucleus, he said there are energy levels. And he also said that within those energy levels, the electrons travel around in specific orbits. Now, the energy level closest to the nucleus, that's called energy level number 1. I can put a 1 there. This one right here is called energy level 2, number 3, and so on. They keep going on and on, right? Depending how much electrons you need. Okay, so I'm just going to draw 3 for clarity, right? So, he said, right, the electrons don't crash into the nucleus because they're essentially, traveling in specific energy levels, and the only way they get out or move from one energy level to another is by gaining or losing a specific amount of energy. Now, they normally call that quanta, but we're not going to stress that too much, okay? So, let's say we have an electron here, right? We have one electron, and you zap it, right, with energy, all right? Put it in a flame like a flame test, yes? It could jump to energy level number 2, and if it gains enough energy, it could jump to energy level number 3, okay? And we agreed before, right? We call that when the electron gains energy going to the excited state, yes? When it goes to energy level number 1, energy level number 2 from 1, or it goes to energy level number 3 from 1, okay? So from 1 to 2, that's the electron getting excited. From 1 to 3, that's getting excited, okay? Or if you have your energy level here, the electron here, if the electron at 2 and it jumps to 3, that's also excited, all right? So going to a higher energy level by gaining energy, that's called excited. Now we agreed, right guys, in chemistry, we'll notice, right, in science, things like to be stable, things like to be in the lowest energy state possible, right? So what happens is the electron does not stay in the excited state. What does it do? It falls back down to a lower energy level as possible, yes? So what happens is it doesn't stay in the excited state, it goes back down to the lower energy level and releases that energy that it gained, okay? So that's the principle behind fireworks, okay? So when you're falling back down, so write it down, falling down, okay, to a lower energy level, that's when you get the release, okay, of the, you see the lights and the colors, and also, we talked about this recently, the spectral lines, okay? So when you look at it in a spectroscope, okay, you can see spectral lines as when the electrons fall back down, bam, okay? So that's what we observe those lines, and we drew those lines like fingerprints, right? So each of the elements in question that we talked about have their own unique spectral lines. Okay, so this is Bohr right here, okay? So he came up with energy levels, he came up with specific orbits, and he also came up with a concept of ground and excited state. Okay, all right, you can see spectral lines when the electrons fall back down. All right, folks, so let's begin. Now, the current model of the atom. Current model of the atom. The current model of the atom is kind of complex, alrighty? Now here's the deal. We now in the regions, right, we don't go into it as deeply as before. Maybe like 10 years ago, I used to teach you guys how to do electron configurations with the current model of the atom, 1s1, one s 2, one s 2, one s 2, 2p, all of 2s1, and blah, 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 blah. Okay, we don't have to worry about that right now, okay, because that's not in the readings anymore. So, you can memorize it like this, PELSO. What does that mean? Okay. The current model of the atom has principal energy levels. That's PEL. Principal energy levels, right? Within those principal energy levels, there's something called sublevels. Sublevels, right? Within those sublevels, there's something called orbitals. Now, this is what you have to know, guys. You have to know the definition of orbitals, right? Now, within those orbitals, there are electrons, okay? Alrighty. So, think of it like this. You got principal energy levels, right? I tell my students normally think of principal energy levels as streets, think of the sublevels as houses, think of the orbitals as rooms, and think of the electrons as people living in the rooms, right? But as I said before, we don't go deeply into this, so don't worry about it, okay? But the key is to what you have to know is the definition of orbitals, right? And orbitals, right, guys, are a region of probability, right, where electrons are most likely to exist. All right, so I'll say one more time. What are orbitals? They're regions of probability, right, where electrons are most likely to exist. These were calculated by computers and very, very complex math and so on, right? Do you have to worry about doing math and so on? No, you don't. Just know this definition. And they always ask you, in the kernel of the atom, where are electrons located? They're located in the orbitals, okay? Or they can ask you, like, what's the definition of orbital, right? And it's a region of probability where you're most likely to find electrons. They're computer generated, and you should Google it, right? The orbitals have really cool shapes. The S orbitals, for example, okay, they have more of a spherical type shape. P orbitals, they tend to look like dumbbells, alrighty, and there's 3 of them, alrighty, oh goodness. I'm doing a horrible job drawing it, right, because, my art history has issues, okay, but just Google it, SP, and there's also D and there's F orbitals too, right, so no problem, okay? But once again, kernel of the atom, know the definition of orbitals. Moving back, Bohr's model, you have to know that there's energy levels to Bohr's model, okay, no problem. And, okay, here, this is Rutherford's model right here. He discovered the nucleus, alrighty, okay? And he did the famous gold foil experiment, right? And we also did Thomson and Dalton from before. All right, guys, study hard, do well, okay? No problem.